Hello everyone. Good morning, dear authors and invited guests. I welcome you to the technical session 1. Myself, Soumya Raut, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the second World Conference on Information Systems for Business Management ISBM 2023, Bangkok, Thailand. The second edition of the conference is being organized in the hybrid mode. The physical event is organized in Bangkok, Thailand today, and the virtual event is being held through Zoom today and tomorrow, that is 7th and 8th September of 2023. This series is organized in extension to the ICT 4ST conference series. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 7 presentations. Please note, in this session, each presenter has been allocated 12 minutes for the presentation and Q&A. It means presenters should finish their presentation in 10 minutes and 2 minutes for Q&A. On 8 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in chat box. Just before we start the session, I would like to introduce you all to the session chairs of this event. So first, we are having Dr. Swati Nikam ma'am. Dr. Swati Nikam ma'am has total 20 years of teaching experience in computer engineering and working as Associate Professor at Pimpri Chinchwad College of Engineering and Research, Pune, India. She has completed PhD from SPPU Pune. Her research areas are cyber physical systems, information security, and Internet of Things. She has published more than 30 research papers in reputed international journals and conferences. Currently, she's working as departmental PhD coordinator, R&D coordinator, and for NIRF, NBA, and NAAC also. We welcome you, ma'am. Next, we are having Dr. Chaya Jadhav ma'am. Dr. Chaya Jadhav ma'am is working as an associate professor at Dr. D.Y. Patil Institute of Technology, Pune, India. She is having total teaching experience of 26 years. She has more than 25 research papers published in international journals and conferences. She has 4 copyrights and she earned 3 patents. She is working as a subject chairman at SPPU Pune and also a PhD guide at Pune University. We welcome you, ma'am. Now, I would like to start with the papers. So, first we are having Ms. Usha Yadav to present her paper on a platform for collaborative lightweight technology development. Ma'am, you may please start with the presentation.
Hello, good morning, everyone. So quickly, I'll just share my screen. So I'll try to stick to my timeline. So my topic for presentation is platform for collaborative lightweight ontology development. This is one of the part of my PhD research. So majorly everything started because we are moving from Web 1.0 to Web 3.0 and so on. So it's majorly inclined towards the semantic web. And because in the Web 2.0 we have grown so much around the social web, there is some issues with the social web that many people are inclined and participating in the social web, but the structure in which we are seeking the information or taking the information on the social web is entirely unstructured. There's no proper hierarchy. There's no way the machine could able to understand. And the vision of the semantic web is to make machine understand the inline structure, understand the data, and infer a lot of potential which we as a human cannot able to do so. So when it comes to semantic web, we have technology in place which provide well-defined structure and standards for our data to allow interoperability of the data. That's one of the main point. So the main core is that how can we club both the world and make it a social semantic web. so that we can allow all the users to participate in creating a structured data, so that the vision of the semantic web, which is to allow the machine to understand the data, we can achieve that. So the semantic web has been slow because due to the lack of mass participation, because we as a user does not want to stick to always providing the very structured data. We do provide some of the meta information, for suppose if we are bound to provide the title, the dates and the hashtags and everything, but the entire information is not well structured. So this is where the mass participation is one thing where the semantic web is lacking, and social web is one thing where the structure is lacking. So we want to integrate both the worlds to achieve something new. So my entire presentation is inclined to the very first module, which is easy onto, but this is just an abstract model of the entire product or platform, you can say. So we start with the easy onto, in which the main motive is to allow all expertise of people to come together to create ontologies which defines a domain, and those would be given as an input to the ontology matching system. Then alignment happen, which by which we can develop our knowledge base, and from there we can have and develop some products which is inclined to the recommendation system and the searching. So Easy Onto, yes, is a collaborative tool in which many people can work together collaboratively and create the structured data. And those structured data are in the form of the lightweight ontologies. So I'll start with the problem identification, what problem I have seek, so that I came to the solution of Easy Onto. So the very first is the lack of user contribution creating structured data. Another is ontology needs to be created depending upon the requirement of different people. Ontologies is what define the domain, right? How we are seeking and perceiving a one domain. But till now, the ontologies development are more inclined or restricted or limited to the some engineer's thought process. But in my opinion, I could say one organization, in your opinion, you can have a different understanding of a domain. So in developing an ontology, which is the base for our machines to understand the domain, should include the perspective and consciousness of all the people of all level, rather than limiting it to the expertise of few engineers, right? That's the main problem. So the objective was to create an environment and create a platform for collaboratively creation of the structured data and the ontologies. So that's why here comes the contribution as a easy onto. So quick literature reviews of the existing platforms which provide such functionalities of creating structured data and ontologies. So this is a tabular comparison of all the existing tools which provide us to create an ontologies, where there's an open, and they have been judged on few parameters such as open source, the import format required, export format, the language on which they have been developed, availability and the storage, and technical use and description. So I'll just there are many more famous are this onto edit and web onto, and there's also collaborative protege. Protege is something very famously used tools for creating an ontologies, but using protege needs a different level of expertise. But because we want to create a platform for the mass users, for every user of any level of expertise, for that we have to keep in our mind that interface should be as easy as to use, interface should be as simple as to understand. So but protege is quite not for all the mass participation, for all the general end users. So yes, easy onto is the main is to create an ontology. It should be confined, it should not be confined to a thinking process of only few ontology engineers. Another is to, it should able to accelerate the entire process of ontology acquisition phase and eliminate any, involving any domain expert in the initial stage. What we do in our platform, we do have a platform and interface for allowing mass end user, the mass participation to create ontology, but still that is the initial phase. In the later phase, we get those ontologies validated by the experts for sure, but at least the entire, because ontology engineering itself is a very complex and time consuming process. So at least for the initial providing the initial acceleration, this easy onto platform will contribute a lot. So what it does, it allow common users to collaborate and create lightweight ontology, the simple easy to use interface, graphical interface for the users. So the flow, entire workflow is that the user can start with choosing a domain or can also add a new domain. Then it moves to adding a new classes, relation or instances, which is the three base required for the ontologies. Then the mapping between the superclasses and subclasses of the ontology, and then the mapping between the class and the relation. After that, the user can also add mapping between the class, relation, instance. Post that, every data, the structure would be taken to the Postgres database, and from there we create a informal ontology. But once the process of validation by the expert, we create and call it as a formal lightweight ontology. So the entire process is quite complex of achieving even to lightweight ontology, but using our interfaces, we try to make as simple as possible for the end users to understand. So this is a prototype of the platform. So first of all, the user will sign up in the home page. User can add. So suppose if I am very well versed with the health domain, so I can start with my health domain only. Or if I'm very well versed with the food domain, so I can choose an existing domain. If you can see in the second snapshot, I can choose any existing domain, or I can add my new domain. Whatever field I want to contribute, I can choose that. The very third is the user can add classes, because when we define a entire ontology, we start with defining the classes. So user can see the existing classes in the corpus and also can add new classes. In the third, if you see the tab, so adding classes, the next one is to add a relationship between them. So the user can see all the relationship lists, and user can add a new relationship and move to the next part. The next part is the add instances for every relationship. So once the user is done with the add instances, it can move to the next part. Once we are done with the classes, relationship, and instances, then comes the mapping between them. So we have a class, superclass, subclasses in case of ontology. So here the user can see the superclasses and the subclasses, and from the drop down menu, the user can see the existing superclass. So the data is fetched from the corpus of the superclasses defined by the users. The next has a subclasses, the data in this drop down
Sorry,
menu.
ma'am, you are left with only 2 minutes. Can
Okay,
you
so
continue with the
so these are
presentation?
the class mapping, and then relation mapping, which classes is related to which one, and the range of that particular class, and then the instance mapping accordingly. So something like that. So if you can see this Postgres snapshot, in this we have created many classes: class, contact, domain, instances. All these classes has been created, and something it looked like this table, which has been further this table. So we have used a tool in which we will be converting our informal ontologies from database to ontologies. So there's a tool DBOL. So from database, it can create an ontologies. So just the experiment evaluation, we set some question for the users, and 70% of respondents were students, 25% were faculties, and 5% others. So we gave them we make them understand about our system and make them understand about the Proteus system also. We get a comparison between our system and Proteus system, and at the end we ask them to show their results or give their feedback. So we can see many users have given their consent that the system are easy onto is simpler, easier to use. 40% of respondents prefer easy onto over the Proteus. And so yeah, so easy onto actually outperform in the categories of task quickly completed, and also it's easy to learn the system as compared to the other system Proteus. So we have done the comparison with the latest used tool for ontology development. So these are the stats. So one is considered negative and 5 being the positive, and we got a really good results in understanding how easy for the user to operate the system, how easy for the users to perform the relationship mapping and everything. So at the end, so it is designed for how the user feel, that is designed for all level of user, or they really need to put a lot of expertise in understanding the system. So many user prefers that it's easy to understand, easy to use, it reflects the error properly, and that's the statistics. So the easy onto allows the common user to collaboratively create. It includes a consciousness of the different people, not just limited to the expertise of the engineer. It accelerates the procedure of the ontology acquisition. And overall, 54.4 people responded that we surely recommend easy onto to other common users as well. So that's my references, and thank you. I think I have done little well on time. So any questions, please?
Yes, Usha, I have one question. Am I audible?
Yes, ma'am. Clearly, you are audible.
Yeah, yeah. My question is, what would be the role of context? I mean, to what level you have considered the context while creating this
Yeah,
ontology?
yeah. So, ma'am, entire ontology is majorly to make machine understand the context of anything. So, if I'm talking about an apple of like a fruit, or an apple of it's like a company. So, we design the domain. We design the structure in such a way that machine understand its context. So, suppose if I'm telling that an apple, so I will write an apple is a company. So a company started on this date, so I will put a relationship started on. So such way, by providing the classes, subclasses, and the relation, we make the machine understand the context very clearly. And then on those structure, it's like a schema. The filling of the data is the later part. The entire ontology is to make the machine understand the context of the domain.
Okay. And what are the exceptions you found
Exceptions.
here or challenges? I mean,
Challenges, the challenges was to, because creating ontology is quite a tedious and a complex task. How easy the interface should look like, what all how the pages should be designed so that the people will understand the existing classes, or we provide the option for self the filling of the information by itself, automatic filling. How easily can user understand the page, and it's easy to understand. That's the main challenge in designing that graphic user layout. That's the main challenge.
okay. And one last question is, what do you mean by lightweight? I mean, what
Yeah.
are you targeting
Yes,
with that
light.
lightweight?
Yeah. So if you have seen, the ontologies have various level of complexity. So whenever it's a high level complexity of ontologies, there are many other properties we attach to the ontology. What I mean by lightweight, it's not that complex. We have not attached and restricted it to various properties altogether. That's why it's a general. It means more like a hierarchy we want the user to create. It's that's not entirely the ontology. Ontology is entirely a very high complex structure. But in the initial phase, we want to include end user, we want to include mass, to at least provide their insight into defining the structure of that domain. So that's we don't restrict them to provide a lot of and add a lot of complex properties to that structure. We have not given those options to the user as of now, which was there in a high weight, or I should say high complex ontologies. That's why we call it as a lightweight ontology.
Because that lightweight even points to, is it related with memory footprint? I mean, in that sense, because we've used that word. So instead of that, maybe simpler, or
Yeah, so, yeah.
this is little contradictory. I mean, lightweight, because whether it is going to memory footprint, calculations. In that sense, are you saying
No.
that? So
No,
that
not
was the
in terms
confusion.
of memory optimization. In terms
Okay.
of defining the structure, entire domain in complex. Like suppose
Yeah. You
if
want
I'm
to make it simpler. Yeah.
yeah. So
Got the
suppose
gist.
if I have a man and a pet.
Okay.
So if I have the information, this particular person owns the pet, the entire system should infer the pet is owned by the person also, without providing the inverse relationship. So inverse relationship and many such relationships are there in the high complex ontology, which we are not restricting and making my end user to get into that. So that's just an initial level of ontology acquisition phase. This project is entitled and inclined towards accelerating that process. It's the complexity of the structure, not how the machine will able to process. Obviously, this is not inclined towards that part. Hello.
Yeah, thank you.
Thank you. Thank you. Okay. Thank you, everyone.
Thank you so much, ma'am. So now I would like to proceed with our next presenter, Miss Supriya B. Roy. I'm sorry, ma'am, it's Miss Supriya B. Rao to present her paper on diabetic retinopathy severity detection and automated tool. Ma'am, you may please start with the presentation.
Yes, thank you. Am I audible?
Yes,
Hello?
ma'am, you are.
Okay, okay. Let me share screen. Okay. So today I'm going to, let me introduce myself. So I am Supriya B. Rao, assistant professor at New Horizon College of Engineering, Bangalore, Karnataka. So today I'm going to present my paper, that is diabetic retinopathy severity detection and automated tools. So how we can, so basically we are dealing with detecting of diabetes. So instead of going for a manual process, we are going to automate. So we are going to use an automated tool for detecting diabetic retinopathy. So yeah, so so first of all, so diabetes is a primary cause for diabetic retinopathy. So first of all, diabetic retinopathy is nothing but the damage that is caused to the retina. So retina of an eye. So because of a high blood sugar level, what happens is a damage will be caused for the retina. So retina that is present inside the eye. So here you can see. So you can see this layer. So this is nothing but the retina that is present inside the eyes. So the main reason for vision impairment is that lesions get accumulated in the retina. So some kind of a small tumor or extra growth might be present on the retina. So this is what is causing the diabetic retinopathy. So who will get diabetic retinopathy? So the patient who is suffering from diabetes, high blood sugar level, will get diabetic retinopathy. So they'll be having the more they are so we are mainly focusing on the patient who are suffering from diabetes. So though diabetic patient are the one who is going to get these kind of this one visual impairment, etc. So manual detection of severity of a diabetic retinopathy requires time, so and which may cause a delay in the cure. So because of which we are going for automation process for a severity detection. And how we are going to automate things, we are using a convolutional neural network. So that is nothing but the deep learning technique. So that comes under a machine learning concept, AML concept. So one algorithm which we are going to use for automating the diabetic retinopathy is a convolutional neural network. And we are focusing on fundus image. So fundus image is nothing but the image that has been clicked using a fundus camera. So which image we have taken? The diabetic retinopathy image, the normal patient image, and the patient suffering from diabetic retinopathy. So those eyes image have been taken for training our model. So we have developed a model where we can learn the features of a retinal image and predict either 5 stages. So we are focusing on 5 stages here. So starting from the early stage, stage 0, stage 1, stage 2, stage 3, and stage 4. So total 5 stages we are focusing on. So 0 is nothing but the mild diabetic retinopathy stage. So 1 is nothing but 9 and no proliferative, and second one is moderate, third is severe, and this one fifth class is very like the person who is about to get blind, so that stage. So next, literature survey. So we have gone through a few papers. So where they have focused on diabetic retinopathy. So in the first paper, they have used artificial neural network, and the data set they have taken is 179 images, so which is very small in number, and the 147 image has been used for training and 32 image for testing. So overall they have got a specificity of 83.5%. So specificity is nothing but identifying the patient without disease, and sensitivity they have got around 88.4%, which means identifying the patient with disease. So this is about first paper, and the rest of the papers they have taken the data set has been varied, and also they have used many other techniques. So here they have used 1273 patient data set, and they have split into training and testing. And similarly, so in the third and fourth paper, so they have taken this one, the data set is varying, and also the techniques. So they have used this one XG boost technique over here. So this is used for optimizing the machine learning model. So this is one kind of technique, and also they have used CNN, and they have achieved the accuracy of a model. So accuracy is nothing but this one, the performance of a model, we can say performance of a machine learning or the deep learning model. So they have achieved around 94.5%. So similarly, in the fourth paper, they have taken the images of around 4,476. But what I can say is we have focused on 5 different classes of diabetes. So, but the literature survey, what we have done, they have focused on only one class, whereas we have focused on nearly 5 classes. And what I can say is we have used a many number of thousands of images here than comparing to other papers. So yeah, so even here, same thing. So they have used images from the IPACs, that is from 3 different hospitals of India, and they have used other techniques, whereas we are using CNN. So here they have used Inception V3. Even this is a part of CNN, but so there is a small variation. So where there are 42 convolutional neural layers and 24 million parameters. So yeah, you can choose your model based on the type of data set you are dealing with. So they have taken various other data set, and so whichever the model that suits the best, so that model they have deployed for those kind of data sets. So this is about my literature survey. So various other papers also, yeah, same thing, but they have used many different techniques, and the data sets are different, and they have given the accuracies also, so 74.5%, etc. So next one is materials and methods. So coming to our project, so we have used IPAC data set. So we have used 35,126 retinal images. So IPAX is nothing but the high resolution fundus image. So the image that has been clicked using a fundus camera. So, and also we have used Aptos data set. So where it has got 3,662 retinal images. So it is available on Kaggle, and a Mesidor 2 data set. So where it has got 1,748. So we have used all these 3 data sets. We have merged all these 3 because getting a data set is quite difficult. So in order to train a convolutional neural network, you need a huge number of data set. So because of which we try to combine all the 3 kinds of data sets here. So next we have done a pre-processing, that is nothing but a removal of unwanted noise in an image, or a removal of blurriness in the image. So all this we have done using a CNN model itself. So preparing the consisted of mainly pre-processing consisted of mainly 3 steps, after which images were reduced. So our images were reduced into 512 into 512 resolution. So images were of a different resolution. So what we have done is, so for further process, for further training of model, so it is better if we keep the image of same size. Okay, so because of which we have restructured or reframed our image into 512 into 512 resolution. Also we have done a certain horizontal and vertical flip. So that is nothing but the images might have a different alignment. Some it might be rotated towards right or left. So we have done certain horizontal and vertical flip to set that image. So this is how the original image looks like. So this is the image of an eye and the retina. So next one is, so this is
I'm
how
sorry,
the,
ma'am, for interrupting you. You are remaining with minutes, so kindly conclude with the presentation.
sorry ma'am.
Ma'am, you are remaining with 2 minutes.
Okay, fine. Okay, ma'am. So this is how the bad image looks like. So by using our CNN, we have increased the resolution of the image. So also we have used various, this one we have used weighted Gaussian a blur method. So using these formulas, these two formulas, we have tried to increase the resolution of the image, and we have removed the unwanted features also. Only the important features we have kept. Later we can train the model using those features only, features from the images. So next, so this is my final outcome. So this is how the pre-processed image looks like. Okay, so if so now it's quite clear. So you can see the clear picture of the pre-processed image. So now we can apply this one. We can train our model using these kind of image, and we can divide the this one data set. So few data we can keep it for training, and few we can keep it for testing. So finally, so after all pre-processing, we have got only 16,041 images. So images which are very much clear. So we have picked only this much, and then we have performed this one. We have built a CNN model. So yeah, so these are the different layers that we have used in a deep neural network. So yeah, so these are the various this one layers. So we have used activation layer, pooling layer, batch normalization layer, dropout layer, fully connected layer. So all these layers that we have enclosed within our convolutional neural layer model. So each and every layer performs a different operation. For example, if I take activation layer, so it suppresses certain data points. And next, if I take pooling layer, it this one, so it performs this one spatial like it performs operation like a spatial size of a featuring map. So each and every layer, so whenever my image passes through each and every layer, one layer performs one operation. So how this layer works, so there is some mathematical calculation that is going on within each and every layer. So yeah, so next this is so total of 50 epochs I have used for my training the model. So yeah, so this is the graph. So this is my graph. So this is my accuracy graph. So yeah, so this is the loss of my model. So next, this is the result. So instead of this, I think I can go for this directly. So what we have done is we have compared our result with all others papers. So so for example, so this is the paper that which I was discussing in the literature survey. So G.G. Gardner, so the paper what the author has written, so he has achieved the specificity of 83.5%, sensitivity of 88.4%. So approach whatever this author has used is ANN. So purpose, so they have used for classification of vessels, hemorrhage, etc. So I have compared my specificity, sensitivity, accuracy of my model with the various other authors. So overall the specificity of my model was 95.9%, sensitivity is 93.5%, accuracy is 75.19%, and this one, the approach that I have used is a CNN, and I have used this model for classifying so I have used 5 different classes, so starting from mild to severe diabetes. So yeah, conclusion. So we have achieved the F1 score of 95%. So that is nothing but my this one accuracy of model. So that is nearly 95%. So with the model being deployed in the medical field, so it automates the process, I can say. So not completely automating, but at least we can assist physicians in so we can help them, or we can just provide facility for physicians for automating the process. So we cannot eradicate, we cannot keep away the physicians. So if you have this one, physicians assistance is also needed. So whereas our models also it helps in automating the diabetic retinopathy detection process. So model can be deployed into computer system with a minimum hardware requirement. So there is no much hardware requirement. Everything is software here. So yeah, so so future work we can do segmentation for lesions such as exudates or hemorrhages or various other kind of eye diseases. So yeah, so right now we are focusing only on diabetic retinopathy. So we can also focus further in detecting hemorrhages, other various kind of eye diseases. Yeah, thank you. Any questions?
I have one question.
Yes, ma'am.
Thank you for the presentation.
Thank you, ma'am.
One question is, what are the exceptions you found during this experimentation?
Yeah,
Where-
exception is nothing but since I'm using this deep learning model, convolutional neural network, we need a huge amount of data sets, so which was quite difficult to collect. So we have found so a few images we have created on our own, and a few images we have created, we have this one got it from a website. So we downloaded it from Kaggle website. So collecting so huge amount of data set was quite challenging.
And any exception you found in terms of detection, severity detection?
Yeah, severity detection, like first of all, the image cleaning itself is quite a difficult task, because whatever the image we get, so if suppose if it is a blur and all, so we cannot just identify the disease, because a retinal is a small part of an eye, right? So we take the eye image, so detecting that retinal part, and then this one detecting whether the person has got a diabetic retinopathy or not. So that is quite challenging in detection.
One question, sir.
Yes, ma'am.
Thank
Yes,
you.
ma'am.
Are you taking any consultations from the doctor side, or are you going to verify your results?
Yes, ma'am. Like we are obviously taking consultation from the doctor side, because we people, we don't know much about these diseases and all. So we have consulted 2-3 doctors, and then we have took their feedback, and then we started working on it. So because we
How
don't know
much is
medical
the
terminologies.
no, what is the comparison between your result? Have you compared that doctor's opinion and your result?
Comparison, no, ma'am. Comparison not yet done. So work is under progress. Comparison has not yet done. And also we are planning to like increase the model accuracy, and we are planning to take much more data sets here. So we are trying to improve the model. So later we can go for that.
Because final consultation and the comparison, then and then we can conclude.
Sorry, ma'am.
Yes.
Final consultation.
Means doctors consultations and your result and their results. Again, if it will be the comparison, that will be the
Yes,
final
ma'am.
conclusion.
Yes, ma'am. That final comparison can be
And
done, and we can conclude.
yes. Another thing is that, are you considering the age factor?
Age factor,
Age.
yeah, right now we have not considered, ma'am.
Huh.
Here, age factor we have not considered. We have just focused on diabetic patient. So diabetic might be, patient might be around 40s also, 50s also. Age we haven't considered.
Okay.
Yeah.
That also it can be considered, because
Yes,
in
yes, ma'am. Yes, yes.
child's also will be diabetic again. It will be.
Yes, ma'am. Yes. Yeah.
Thank you.
Yeah.
You,
Thank you.
Supriya.
Thank you so much for the valuable feedback. Thank you.
Thank you so much, ma'am.
Thank you, ma'am.
Now, I would like to call our next presenter with paper, Rohan Mehta, to present his paper on advanced speech to presentation automation. You may please start with the presentation, sir.
I'll just share my screen 1 second. Is my screen visible?
Yes, sir, it is.
Good morning to one and all present here. I am from Advanced Speech to Presentation Automation. Our project ID is 243. Our project guide is Professor Srinivas KS. And our team consists of Medha Koppam, Rudransh Kulkarni, Shruti Pai, and myself, Rohan Mehta. We are from PS University, Bangalore, India. So according to a recent study by the America's Promised Alliance, the US had a 30% rate of students failing to graduate high school. 1.34 lakh students scored above 90% in the CBSE 12th board exam. And JEE Mains, which is the exam to crack IIT, which is a concept-based exam, the top 10 percentile of the students had an average score of just 110 out of 300. This shows that the same students who scored 90 plus in boards were struggling to even score 30% in a concept-based exam. A recent study from Harvard also found out that when people were prompted to use verbal thinking, they created visual images to accompany their inner speech, suggesting that visual thinking is deeply ingrained in our brain. If a relevant image is paired with some information, it is seen that 65% of times the information is retained in our brain rather than just 10% times when it is just textual matter. This led us to our problem statement that schools in India do not even have internet, let alone digital content. Many students fail to grasp the fundamental concepts of each unit or each chapter, and when they are taught in the conventional textual method. Schools shy away from hiring curators, designers, and other people because it costs because there is high expense involved in that. And summary tools for topics taught in schools are hardly provided to students. Looking at this huge problem in mind, we came up with our solution in the form to promote digital content in the form of AI-generated presentations with relevant graphics, important text, 3D dynamic models, lecture summaries, assessments, and external further reading in the form of educational links. All this is in an easy-to-use editable .pptx format, which .pptx format that is completely customized to the institution's liking, resulting in a simple, comprehensive, and holistic approach and saving hours of human time and effort of teachers. Just to show a little input and output, the speech will be taken as input from the teacher. The black box shown here is our model, and it will generate a presentation which consists of text, relevant images for the text that is present in the particular slide, summaries, question and answers. First, we set out to actually look at some of the models that are already present in the market by doing some literature survey. The first paper we studied was semi-supervised NMF models for topic modeling in learning tasks. Some of the pros of this paper was that it enforces non-negativity constraints on the factorization, which is used for discovering latent topics in the text data. The computational efficiency of this NMF model is also very good. Next paper was Visual GPT. The takeaways from this is that it was a data-efficient image captioning model, which leverages the linguistic knowledge from pre-trained language model, which allows us to better our dataset and generate accurate images for the presentation. Automated news summarization using transformers. It has one of the couple of pros of this paper was that versatility. TFI is a text-to-text transfer model, which means it can be fine-tuned to a wide range of text-to-text tasks, such as summarization, translation, question answering, and more. It also has multilingual support that TFI can be fine-tuned for multiple languages, making it valuable for summarizing text in different languages, maybe regional. High-resolution image synthesis with latent diffusion models. It is a clip text for text encoding. It consists of the UNet plus scheduler to gradually diffuse information in the latent space. It has an autoencoder decoder that paints the final image using the processed information array. The latent diffusion model improves the computational efficiency. latent nerve for shape-guided generation of 3D shapes and textures. One of the pros of this paper was that it uses LDM, a similar specific form of diffusion model that is trained to denoise the latent codes of a pre-trained autoencoder instead of the high-resolution images directly. Learning to ask neural question generation for reading comprehension. It is a fully data-driven neural network approach to automating question generation for reading comprehension. An attention-based neural network approach for the task and investigates the effect of encoding sentence versus paragraph level information has been used. Coming to the competition that are already present in the market, we have depicted them in two axes: ease of use, that is number of clicks to the output, and education oriented, that is related to the education sector. We can see Chroma.ai, Wengage, Designs.ai, Beautiful.ai, Pitch have a lot of steps involved resulting to the output, and therefore the ease of use is very less compared to Advent, which is just a one-click output. And these are all not related to the education sector and therefore not adhering to the audience that we are looking at. Coming to the proposed methodology that we have formed, that our model is working on. First, when we take the speech input as text, it is important to convert it, speech input, it is important to convert it into text so that the summarization processing can all be done and the prompts can be passed for image generation. So this is done through simple assembly AI API, which is a custom built deep neural network architecture. Once we have the text in the .txt file, it is just a chunk of text, and therefore the topics needs to be detected to know what chapter this is and certain topics, which is done through the NMF model. And it takes the input matrix is usually a document term matrix where each row represents a document and each column represents a term. At the end of NMF model, we have topic detection with certain topics with their certain keywords. So now we pass each sentence through these topics and distribute them accordingly under each topic. So at the end of this pre-processing, we have a topic and a chunk of paragraph or 2 to 3 paragraphs that are there under each topic that needs to be summarized. For the summarization, we are using GPT 3.5. The GPT 3.5 is fine-tuned by customizing various parameters such as temperature, max tokens, talk P, frequency penalty, and presence penalty. This is done to improve the summary quality. And it is also important to note that we were looking at a summary that is both abstract, that is a mix of abstractive and extractive, because we did not want the important points or keywords that were told by the teacher to be missing from the presentation deck. And that is why we have fine-tuned this GPT 3.5 model to actually make it relevant to the education sector and optimize the model's output. After the text is summarized, it is put into the presentation using the Python PPTX module as bullet points. And each bullet point is then passed to the stable diffusion model as a prompt. The stable diffusion is used for image generation, and it is a text to image diffusion model by Stability AI. We are using the Dreamboot implementation and training the final layer while keeping the remaining of the weights as it is for the model. By training the final layer, it helps us to narrow it down to the education sector and make it relevant for our tool. Therefore, now at the end of the stable diffusion part of the tool, we have a slide which has 3 bullet points and 2 images that are relevant to these bullet points through stable diffusion. In the end, we have question answer pairs from LangChain. Our model takes in a text document as input and generates question answer pairs from it in the form of a dictionary, which has the question and a question as key value pairs, question and answers. Therefore, this is large language model at the end, which generates question answer pairs for our model that can be used for assessment, not only by the students, but also by the teachers to actually help the class. At the end of this is all compiled into a presentation and given out as a .pptx presentation. So some of the comparison that was done between various summarizers was through some evaluation metrics such as ROPE score and the CHRF score. We had used different models while training it on our data set, which was BART, T5 Base, BERT, GPT-3 DaVinci, and GPT 3.5 Turbo. It was all compared to a ideal summary that we felt was a mix of abstractive and extractive. And we saw that GPT 3.5 Turbo gave us the maximum, gave us the best results from these evaluation metrics, and therefore we went ahead with it. Similarly, the various image generation models present in the market are Stable Diffusion, DALI, and Midjourney. So these were compared with a small data set of 676 images as well as 5,000 images. The real images, it was seen in both the cases that Stable Diffusion, the score for Stable Diffusion images was as close to the real images when compared to DALI and Midjourney. In addition, it is also important that to know that Stable Diffusion is an open source code, and we can use the Dreamboot implementation to actually fine tune and train it on our for the education sector. But DALI and Midjourney do not allow us to do that. This was a simple small input that we had given the model, and this was the output that was. This was the screen. This is a screenshot of a slide where the topic is detected on its own. There are various bullet points and 2 images that are relevant to the bullet points. So there were 3 slides that were generated from the small input text that we had given. In conclusion, we have conducted the feasibility study and identified unambiguous problem statements. A comprehensive literature survey was done and designed an architecture for the various models, or as explained, is as follows. Thank you. We can open the floor for questions.
Yeah. Thank you, Rohan. Thank you for the presentation. My question is how it would process the context again.
For the text, ma'am?
Yeah.
For the NMF model, it is the TF-IDF score that's been taken. And so each sentence is passed through each topic and the keywords. So that is where like the context is passed, that under each topic, this sentence is being put away.
Hello.
Yes, ma'am.
How much is it completed 100% with all aspects?
Yes, ma'am. This was the output that was generated by the tool. So it is completed 100% for the geography subject.
Okay.
Yes, ma'am.
Okay. Means is it in use right now, or
we have tested it with some of the teachers in like middle school and high school. They are open to using it. It's not being used fully as such, but we have tested it with some of the teachers to gain their feedback of how we can change a little bit. So we have done that little feedback round.
okay? Means are you planning only for the schools only?
To start off, yes, ma'am, for high school and middle school people, students.
Okay. Thank you. Thank you.
Thank you.
Thank you so much, sir.
Yeah. Just a second.
Okay, now I would like to call Mr. Rituraj Naventikar to present his paper on enhancing criminal identification, human face deblurring, and mass detection using convolutional neural networks. Sir, you can start with your presentation.
Yeah, so I'll start by sharing my screen. Hopefully I'm audible and my screen is visible.
Yes, yes.
Yeah. So good morning, everyone. Our topic is enhancing criminal identification, human face deep learning, and mass detection using convolutional neural networks. So my college name is ISBM Shahu College of Engineering. My group members are Kranti, myself, Rituraj, Maithili, and Sairaj. My project guide was Professor Pushpavati Kanaje. So I'll start by introduction. Deep learning is actually to remove the distortions and restore a clear, high quality image. Uh, blur can be of different types, like motion blur, Gaussian blur. These blurs are actually caused by the object actually moving, or the camera itself is moving, or any disturbance between the object and the camera. CCTV cameras can have blur because of variety of different factors, like the identified thief can be covering his face, or the weather might not be clear, or the CCTV might produce some image fuzz. Okay. So what was our objectives? Like we have to deblur the face. If the thief is wearing a mask, we have to predict his face. This is actually for criminal identification, and we are in the very early stages of this project. Actually, we referenced about 17 of the papers and found four deblurring methods which were very good. So I'll start by what is deconvolution. It is just a technical word for deblurring. It is the reverse of a blur applied. Like in Snapchat, we use filters which actually do convolution, which is a mathematical operation used to apply blurs. Deconvolution is actually a really tough task. In convolution, we just use a matrix to apply the kernel of the image. And for deconvolution, we have to predict the matrix, which is large in size. And for face detection method, we are using the Ansible method. It is a method actually generally we can use anywhere in a life. This method says that instead of relying on just one method or model, we can combine multiple models to make accuracy boost. Like the five models mentioned: single shot, multi-box detector, YOLO, faster RCNN, and these methods actually we can use to boost our accuracy. As expected, this is how a workflow should be. And since we are very early in the stage of development, this is what the predicted is. And we are using semantic segmentation dataset to detect the facial features of a person or to predict the features. And this will be a software and hardware requirement. Keras for actually processing the datasets. And Java will make front end through Java. Thank you. I am open to questions.
So, Ruturaj, I have not
Yes, ma'am.
understood that what technology and what we are doing in that algorithm, which algorithms we are using. Or, that's
Ma'am,
technically
actually, we use a mixture of these algorithms in the CNN.
what about your results?
Sorry, ma'am.
Results.
Ma'am, actually, we are very early in the stage of development and we haven't actually done anything yet. We have just created the data set of semantic segmentation to detect the facial features.
Just created the data set.
Yes.
Okay. The source of this data set, from where we have collected the data sets?
Yeah, actually, we created a Google form and circulated in our college for just people uploading their faces. And we gathered around 500 images.
No. Your topic is enhancing criminal identification. How will you get
Yeah.
the data of
Yes.
college? That your title is criminal
Actually, the facial features of humans are almost same, like their eyes. We are just processing the facial features like eyes, eyebrows, lips, ears, nose. That's all.
Thank you. Swati madam, any question?
No questions, please.
Thank you.
Thank you, sir. Now, I would like to call Indrani Vasiviti to present her paper on pod migration with optimized containers using precedent volumes in Kubernetes. Ma'am, you may please start with the presentation.
Yes, good morning, everyone. I'm sharing my screen. Is it visible?
Yes.
Yes,
Yeah,
ma'am.
thank you. Thank you so much. So good morning, everyone. Today, I'm going to give a presentation on the topic pod migration with optimized containers using persistent volume in Kubernetes. I'm Indrani Vasreddy, a research scholar at School of Computer and Information Science, University of Hyderabad, India. I'm doing this research under the guidance of Mr. Rajiv Vankar and C.R. Rao sir. So today I'm going to discuss about containerization. Before going to the topic, I want to just give a brief introduction about what is a container and what is a role of Kubernetes in containerization. So a container image is a ready to run software package containing everything needed to run an application. So in the containers are the lightweight form of virtualization with which packages the applications and their dependents together into single unit, so that what all for example, when a developer is developing, when he has to give when he has to send the same code to the testing side, if the system is not compatible with the developer's configuration, then the tester may not find it compatible. So to overcome all these issues, the containers are used so that everything, the libraries, files, everything required are packaged as a single are packaged into a single application and environment, and they are given to the tester. So different types of containers are there, like Docker, Linux, Podman. So to maintain these containers or to manage these containers, we are using Kubernetes. So Kubernetes is an open source container orchestration system. It is for only for managing the software development, for scaling the containers and managing of the containers. It is developed by Google. It's a GKE, Google Kubernetes engine. So containerization simplifies the application development management in the cloud. So we will use, to manage these containers, we will use Kubernetes. So Kubernetes cluster architecture consists of master and worker nodes, and the pod, the word which I'm using here, the pod, it resides in the worker nodes of the Kubernetes cluster. So here is a simple diagrammatic representation of the Kubernetes architecture and how a pod looks in a Kubernetes architecture. So this is the master node, and this is the worker nodes. So the master nodes will have the API server, the scheduler to schedule the pods to the worker nodes, and the API server to act as an interface between the master and the worker nodes, and the controller and manager to manage the worker nodes and the pods. So the etcd is the database for this Kubernetes cluster. So coming to the worker node, here this is the pod. Like Kubernetes, the containers are reside inside a pod. The container can be of a Docker, a Podman, or LX, or any container, but it resides inside a pod. So pod is the smallest deployable unit in Kubernetes. So how it can contain a single container or more than one containers. So the containers inside the pod share the storage with the help which is known as volumes. So they communicate with each other within the pod with the help of volumes. The volumes are the shared resources inside the pod, shared database storage resource inside a pod. So what happens is, for example, if a pod is killed, the volume is deleted. That means the life cycle of the life of a volume is dependent on the life cycle of a pod. So if a pod is killed, we will lose the data of the containers, as the containers data is stored in the volumes. Hence, here I had proposed the persistent volume. So persistent volume is additional storage inside the cluster or anywhere inside outside of the pod, which is independent of the life cycle of a pod. So here in this, this is the Kubernetes architecture and how a pod looks inside the worker node of a Kubernetes architecture. So pod is the smallest deployable unit, and it is a collection of containers. So this kubelet and kubeproxy, they are used for managing the containers inside the Kubernetes cluster. So what is the persistent? Main thing I want to tell you about a pod is, a pod once it is killed, it cannot be recreated. Like for example, if a pod is paused, like for addition of containers or for any modification, once it has been in the pause state, it cannot come back to the running state. Only thing it has to be done is it should be killed and recreated. We cannot get it back to the running state. So what are the persistent volumes, which word I had used in my topic is, the persistent volumes are the storage resources which can be provisioned using dynamically or statically, but the life cycle of the persistent volume is independent of the pod life cycle. That means even if the pod is still, we can get the data of that containers or of that pod inside the persistent volume. That means if we can attach a persistent volume to a pod with the help of a persistent volume claim. So unless we have that claim with us, we will not lose the data which is present in that persistent volume. So they exist beyond the pod termination also. And even when we after killing of that pod, if we recreate a pod, then we can attach the same persistent volume to the pod so that it can, again, we can restore the data. So this is about the persistent volume. Next, I had used a tool like Creo. It's a checkpoint restore in user space. Creo, it's a Linux software, and it is used to freeze a running container and capture, like it's nothing but in database how we assign the checkpoints, and we can roll back to that saved points, and we can roll back to that particular saved points. In the same way, here we can get the states of the containers inside the we can freeze the state of the containers, and we can restore it back at that particular time, till that particular time. So where we can use this Creo is to when we want to freeze the application and restore it whenever we want, or when we want to have a live migration of processes between different hosts or containers. And if we want to for debugging, developers will use Creo. Mainly it is used to checkpoint, save the data, and restore. So to save the data, where we are saving is, we are saving it on the persistent volume. We are saving it in the persistent volume. So this is the proposed pod life cycle which we had proposed. Like a pod will be initially a set of pods will be in the pending state. And once a set of containers are assigned to a pod and the containers are started running, now the pod will come into the running state and it will go on executing. But in the middle of the execution, if we want to update the containers, or if there is any lack of resources in that node, or if any additional containers have to be added to that pod, it cannot be done. Simply, it will be killed. So there are two ways. If all the containers for example, if there is an under resource at that node, and if all the containers has completed their execution, then it is successful. The pod has terminated successfully. So no need to restart that pod. But if the pod has some containers which have still in running state only, and some have completed its completed state, then comes the issue. Like now the pod will be recreated. So when the pod has to be recreated now, it will be recreated from the scratch again with all the containers which had completed their execution and which had not completed their execution. So for example, if there are n containers, and inside that, if n containers have completed their execution, then if we can remove those n containers, that means if we can restore a pod with m minus n, then we can optimize the resource usage in that Kubernetes cluster. So while recreating a pod on a new node. So this is that's what I want to go with an optimized container. So this is what it's meant by an optimized containers. That means we want to recreate a pod with by scaling out the containers which have completed their execution, as it is not required to execute as not required further. So what are the benefits and challenges of pod? Are resource sharing. There is an efficient resource utilization within a pod, and we can manage the related containers as a single unit, and we can communicate. Containers in the pod can communicate easily. So these are the benefits of the pod. Now, what are the challenges? The first challenge already had discussed, like if the pod is failed, the Kubernetes will recreate it. So this will lead to a downtime and in a disruption in service. So and pods are designed to be stateless by default. If I want to make them stateful, I have to take some careful considerations like using persistent volumes and availability and all. So when the pod has to be recreated, if we can, if it has to start again from the initial state with all the containers and libraries and all, so it can be a delay in service due to the time required for the container initialization. So the traditional pod migrations which are present here will lead to downtime and resource inefficiency. So what are the gaps in the existing? They had several research has.
You, but you are remaining with 2 minutes. So kindly conclude with the presentation.
Yeah, I'll conclude. I'll conclude. So what are the gaps in the existing researches? There is a lack of focus on live pod migration, and the container state preservation is not done. They are preserving the states of the container, but not at the killed state, So when the pod is killed, at that time, the container state should be preserved, and we have to recreate a pod from that point of time. So that is not available in the existing research. And CRIU integration has been done only by one literature survey. So what is the main contribution is we had made the container state preservation, and we had minimized the cold start time. So we had extracted the state of the containers, and we had stored the container state in a persistent volume. So while extracting the state, we had used CRIU to freeze that containers. We had extracted the state, and we had stored it in the persistent volume. So when we want to recreate a pod again, now we will restore the states from the persistent volume, which was freezed by the CRIU. So using this, cold start time has been increased, and we can even improve the development speed and resource utilization. So this is the various related literature survey. But no one has tried to do the pod, capture the state of the pod at the time of killed state. So we had done that. And the proposed pod migration technique is in 3 steps. We can create multi-containers for a single application. We can capture and store the states in persistent volumes. And we can use CRIU to freeze that state. And during migration, when we can retrieve the states from the containers, and we can use the state of the container. So completed containers will be scaled out, and now a new pod will be redeployed with only the containers which are in pending state, not in completed state. So this is the design of the proposed pod migration. So for example, this is node 1 with pod C1, C2 and volumes. So I had used a persistent volume and a migration coordinator. So the persistent volume will store the data of the container. So when migration coordinator, when CRIU it's triggered, then the CRIU will take the checkpoint the states into that will checkpoint, and it will be now the new pod is created as C2 is being completed. Only C1 is in pending state. So a new pod with new volume, but the data is taken from the persistent volume is being used. So this is the proposed pod migration which we had done in this paper. So this involves the migration is triggered and the states are captured. So after capture state, we'll see which ones are in completed state, and those will be removed. And we will redeploy a new pod on a new node with only the containers which are in pending state. So this is the evaluation report. So this is a pod which I had done with the traditional pod migration. Like all the containers are recreated. So then this is the cold start time of the traditional current pod migration. This is the cold start time for my proposed pod migration technique, which where the one container has been completed. So I had removed that, and I had recreated a pod only with the pending container. So now the cold start time has been reduced. So they had done this evaluation on by performance of a Kubernetes pod over a series of 50 iterations. And this is the memory utilization and the CPU utilization and the cold start time, which has been reduced. So what is my conclusion is, like we had used the current pod migration techniques will recreate a pod with all the containers, whether they are completed or pending, if the pod is killed in the middle. But in our proposed pod migration, what we are doing is, we will capture the state of the containers at the every time, but at the kill state also it is captured because we are checkpointing it with CRIU. And now that captured state is stored in the persistent volume. And while recreating a persistent volume, while recreating a new pod on a new node, we will use the persistent volume data in the persistent volume and remove the containers which are in the completed state, and only the containers which are in the pending state are redeployed on a pod on a new node. So thank you for giving me this opportunity. Thank you very much.
Thank you, ma'am. I have one question.
Yes, ma'am.
These pods are stateless.
Yes, ma'am.
Then how do you
we can use stateful also, ma'am.
Okay, you have used stateful. And
Yes,
is it
ma'am.
the live migration?
It's not a live migration, ma'am. By next step is live migration, ma'am. So that's what we had. Live migration will have require some more considerations. So we had done only the pod migration by using persistent volumes only.
Okay. Thank you.
Thank you. No question.
Yeah. Thank you, ma'am. Thank you so much.
Thank you, ma'am.
I'll stop sharing.
Now, I would like to call Mr. Brandon Gomez to present his paper on Safe Tickets Sale Safely, supported by blockchain and NFTs. Sir, you may please start with the presentation.
Okay, just wait a minute. Okay, I think it is visible now.
Yes, sir, it is.
Okay. Okay. Well, good morning, everyone. I'm going to present my paper, which is titled "Safe Tickets Sale Safely Supported by Blockchain and NFTs." Okay, so we're going to start as a short introduction. I am going to present some background and how we address the problem, right? Okay, so first of all, we have two ways of ticketing. The traditional ticketing that requires a physical space and a face-to-face interaction. The classical interaction between the ticket provider and the user. As an alternative to the traditional ticketing, we also have the e-ticketing, or well, the online ticketing, which you only need an application or an internet platform to buy tickets. The thing is that in both of these cases, in both of these ways to buy tickets, there is a common problem, which is the ticket resale scams. So just to give a small statistic, in the United States, 12% of ticket buyers have been victims of resale scams, and this represents losses of nearly $2 billion. Now, moving on to the context in where this project was carried out, which is in my country, Peru, I am going to show you some statistics regarding to the Peruvian context of this problem. Okay, this is based on the multisectoral situational diagnosis on cybercrime in Peru. This document was created by the Peruvian Ministry of Justice and Human Rights. So we can see in the graphs that, for example, the number of cybercrime complaints received by the Divindat, which is the organization in charge of cybercrime complaints and frauds, we can see that the complaints in the past years has been rising and almost 3 times from the 2015, right? And also that most of these complaints are regarding about cybercrimes against assets and computer fraud. And in this category, the ticketing sale resale scams is well, it belongs to this category, right? So we can see that the problem of ticketing resale scams is something relevant for the context of the Peruvian people. Okay, so now what is our approach to solve this problem? A solution that allows secure ticket trading between official ticket providers and users, where tickets would be represented as NFTs in a blockchain network. Okay, due to the nature of NFTs, this allows tickets to be easier to transfer among the blockchain. It could be between a ticket provider and a user, or even amongst users, because of the nature of the NFT and blockchain. Also, price speculation, which is very common in ticketing resale, should be, well, will be or can be handled by the transaction policies, and these transaction policies can be defined by smart contracts, which are also part of blockchains. Okay, moving on. We have a small literature review or related works. For example, we have this paper title in which blockchain technology as a mechanism for digital railway ticketing. Blockchain technology was used to address the same issue, but regarding ticketing in railway ticketing, right? And this was in the United Kingdom. Another paper was NFTs in practice, non-fungible tokens as core component of a blockchain-based event ticketing application. And the resulting prototype considers two main actors, event organizers and attendees, which is very similar to our approach that we are presenting right now. Also, we should notice that users can acquire and trade tickets, allowing for the development of secondary markets within the same platform. Moreover, another couple of related works. For example, we have ticketing system based on NFTs, where authorized sellers join as nodes in the private blockchain network and generate tickets, which are distributed to both secondary markets and general users. And moving on to the next article, secure events tickets on a blockchain. This was developed with Hyperledger Fabric version 1, and this addresses the security aspects associated with protection against multiple ticket resales and the sale of invalid tickets. Move on. Okay, now presenting the method and contribution of this paper. First of all, we should know that this is how our project was carried out. No, so for the development of the mobile application, we divided this into four layers. First, we have the presentation layer, in which is the Safe Ticket app. This app was created using Flutter, a small app, just to give some demonstration of how we can use the NFTs and blockchains. This application communicates with the business layer, and which is an API, is the Safe Ticket API, and is created using C#, actually using the .NET Core framework, and also to integrate with the Ethereum blockchain, which is the one we are using. We use the Ethereum SDK, and also to persist some data regarding to credentials and stuff regarding authentication. We use a simple database in SQL. Now, regarding to the flow of this project, of this solution, we can see that first of all the partner, which is the ticket provider, creates an event using the app, and also when an attendee buyer needs to buy a ticket from this event, he also uses the app, and this makes that the mobile app calls to this Ethereum SDK to update the information regarding the event, and also to retrieve an NFT to the attendee, also by using the app. Also, we have an experimental protocol and some results. This experimental protocol was carried out in the capital of Peru, in Lima, and its objective was to verify that Safe Ticket provides the necessary guarantees to users in the ticket buying and selling process. We had a sample of 70 individuals, also considering a confidence level of 90% and a margin of error of 10%. We show these two graphics. In the first one, we can see the perception of users regarding safety guarantees provided by Safe Ticket, and we can see that most of the users, well, around 60%, have a positive perception of the solution of Safe Ticket, and some of them, well, 34% has a regular perception, and just 4 of them, which represents the 6%, have a negative perception of the application. And also, we asked about how the people feel about the guarantees given by Safe Ticket in comparison to another platforms that exist in Peru, and most of them say that they felt the same, and also a slightly better performance in guarantees regarding the safety problem. Okay, moving on. We have a small discussion of the results. We can see that around 94% have from a regular to a positive opinion regarding the performance of the ticket, talking about security and that stuff. But we also noticed that there is a 6% that strongly rejects the solution. And we can probably say that this may be because of prior distrust or a preference for traditional physical tickets. And also the room for improvement that was given from the feedback from the users. They focused on the user interface, which was kind of surprising because they didn't give technical specifications or like. Finally, we have some conclusions and perspective. And we can see that Safe Ticket is presented as an alternative for online ticketing by integrating emerging technologies such as blockchain and NFTs. And also, a physical ticket sale should be provided to meet the need of people that is still not comfortable with the virtualization of the online ticketing sale process. As we see, there is around a 6%. Also, future implementations of ticketing platforms should consider using network blockchain networks that may fit better the specific business domain because, for example, the network that we use, which is Ethereum, is a general purpose network. And for example, there may be other alternatives that could fit better this specific domain. And also this work can be extended to fulfill the needs of other areas that rely on ticketed distribution. For example, transport ticketing systems or like, so yeah, and that's all. Thank you very much.
Yeah, thank you, Madam, for your wonderful presentation. My question is, what would be the impact of automated bots in this blockchain ticketing?
What will be the impact of
Bots,
what?
bots.
Okay. Well, that is something that in a first instance we haven't considered, but in that case, there should be a regulation regarding that in order to avoid getting, for example, that these bots get all the tickets in the network, and there may be again the same problem of reselling, right, by using these bots. So yeah, that is an interesting opinion, and that we should also have for future perspective. And yeah, I can acknowledge that there is room for improvement regarding your opinion. So thank you also for your question.
Yeah, I mean, I think it needs to be considered because if you want to detect the forgery, you want to prevent the forgery of tickets, right? So the impact of bots should be considered. Okay. Okay,
Yeah.
thank you.
Thank you so much, sir.
You are not audible, Soumya.
Ma'am, now I'm audible?
Yeah.
Okay, ma'am. So I sincerely thank you all the authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the second version of the previous first version of the conference. We will happy to have you all in the third version in 2024. All the presenters would be getting the digital certificates through Gmail within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ISBM 2023. I also thank our session chair, Professor Swati Nikam ma'am and Professor Chaya Jadhav ma'am for chairing the session. A token of appreciation to the chair on behalf of the team ISBM 2023 and Global Knowledge Research Foundation partners, I also request our session chairs to enlighten me as well our hardworking presenters with their beautiful words.
Thank you, Soumya, for this wonderful opportunity to hear from all the participants. So no doubt they have touched many latest topics, many emerging areas of the problem statement. They have worked on it, and the interesting were the results also were very interesting. So I wish them all the best and hope to see you in future to hear from many more participants, many conferences. Thank you so much.
Thank you so much for giving this opportunity, and the selected papers were in all the areas. Now I can congratulate all the authors of this paper for wonderful presentation. Hoping this again cooperations from this side. Thank you so much.
Thank you so much, ma'am. I request all the presenters as well as our session chair to kindly turn on their camera for a quick snapshot. Thank you all. Thank you so much for a valuable time.
Thank you.